Respected teachers and fellow friends, a very good morning to everybody present here and a warm welcome to Forensis, the, the curricular enrichment program organized by the Forensic Science Club at Krista Jayanti College. Without taking much time, I'm handing over the session, the first presentation of the day. We have Ms. Elizabeth Deepika Ponnuraj from 5th semester Forensic Science presenting an e-poster on working on Breath Analyser.
Okay. So as you all can see on the screen, my topic for today is breath analysis and its facts that you all need to know as a forensic science student. Today, my talk is particularly relevant to those of you who have party plans for this weekend and you're having a few shots with your friend. So in that scenario, I would like to caution you from making an incredibly dumb decision to get behind the wheel. And if you do so, you might see those blue lights in your rearview mirror and an officer pulling out one of these. Think you can beat the test? Forget about it, because chemistry will land you in cuffs. A very good morning to one and all present today. This is Elizabeth Deepika Ponnuraj from 5th Sem BSc Forensic Science. Come, let's learn more about this breathtaking invention. A breath analyzer. A breath analyzer is a device used to determine blood alcohol concentration, or BSE for short, by measuring the amount of alcohol in a sample of your breath. But did you know that the breath analyzer test is based on an oxidation reaction of alcohol in chemistry? Let's see about it. In the 1950s, Dr. Robert Brokenstein of the Indiana State Police invented the breath analyzer, a type of breath alcohol testing device used by law enforcement agencies. Nowadays, people commonly say breath analyzer when they refer to an alcohol test. However, breath analyzer is actually a brand name. Now, let's understand the working of this competent instrument. There's a 1 cc breath sample that's taken by the instrument. It's placed into what is called a fuel cell. This fuel cell, all it does is react with alcohol, and there's an electrical discharge that will take place from the fuel cell. And there's a direct proportion depending on the amount of alcohol that's in the breath sample to how much electricity will come out. At this point, I can sense that most of you all are wondering, how does your breath give away how much alcohol is present in your bloodstream? Let me explain this for you. With your breath, there's a direct correlation between the percentage of alcohol that's in your blood and the breath that's expelled. There's a 2100 to 1 ratio there. We can measure the amount of the air, and the air is going to have the same proportion of alcohol in the air that's coming back out as what's in the blood that's flowing through your body. It turns out that once ethanol, the alcohol found in beer, wine, and liquor, is absorbed by your stomach and moves through your liver and bloodstream, a tiny fraction of it makes its way to your lungs. And this is how alcohol moves from the bottle into the blood and to the breath of an individual. So guys, whatever I had explained or elaborated till now are just basic layman understanding. And you all do remember that we are forensic students, right? Students who learn everything to a great detail to aid criminal investigations. So with this perspective, let's get down to the chemistry of alcohol breath analysis. As I told you earlier, the major component in a breath analyzer is a fuel cell. And basically, there are two processes that occur inside a fuel cell. Firstly, the fuel cell is filled with dichromate ion in acidic solution. In the solution, the dichromate ion has an orange color, but the chromium ion is blue-green. This reaction is easily observed because the orange color disappears as dichromate ion is used up, and the blue-green color appears as chromium ion forms. If there is enough ethanol present to react with all of the dichromate ion and use it up in the reaction, the orange color will disappear entirely and the solution will become blue-green. On the other hand, there may be only a little ethanol present related to the amount of dichromate ion present. In other words, there is not enough ethanol to react with and use up all of the dichromate ion. In this case, some orange colored dichromate ion remains after the reaction, along with some blue-green chromium ion that is formed due to the reaction with a small amount of ethanol present. This mixture of orange and blue-green ions will produce a solution that is golden yellow color. This is what tells us or indicates the presence of alcohol in a sample. And this reaction is also referred to be known as qualitative analysis. And finally, we have the quantitative analysis that helps us to understand if a person is drunk beyond the legal limit. Here, the fuel cell consists of two platinum electrodes that are partitioned by a porous acid electrolyte material. As exhaled air passes through the fuel cell, the platinum oxidizes any alcohol present and produces acetic acid, protons, and electrons. The electrons flow through a wire from the platinum electrodes and reveal the BSC. The strength of the current corresponds to the volume of alcohol present in the sample. And please note that it is not necessary for a breath analyzer to have both the processes. However, there are few situations in which a breath analyzer may fail to measure BSC accurately or produce results what is known as false positives. For example, individuals with higher than normal levels of acetone in their breath may have it detected as ethanol. This could include diabetics, both those on fasting diets or those adhering to a keto diet. There are few other substances that could interfere with the chemistry of a breath analyzer, but thankfully not the ones that you may likely to have in your bloodstream. There are some statistical studies that I've researched about this topic, which I've mentioned in the poster. On the left of the third segment, there is a funnel chart that I have inserted, which gives us data about different age groups involved in crimes reported under drunk and drive. Further, a point that I would like to highlight here is in India and even in most of the countries, 0.08 BSC is set as the legal limit beyond which the driver is considered to be legally drunk. And hence, most of the chronic alcohol consumers have a breath analyzer installed in their cars. And at the end, I've also listed few advantages and disadvantages for your benefit. And if you're also wondering why have I scattered those images in my poster, then it is because these images are relevant to our topic, as the first picture shows us a typical breath analyzer instrument and a person using one in the next picture. And further, the next image shows us a variety of alcohols that are commonly consumed in the recent times. And the rest of the pictures depicts the aftermath or after effects of driving under the influence of one. Finally, the last image is just a meme related to the topic to capture all your attention. As I conclude my presentation for today, I would like to thank all our faculty members and the club coordinators for giving me this wonderful opportunity, because gratitude is the healthiest of human emotions. Thank you.
I invite Ms. Shreya KattiRiya, Ms. Siddhi Pant, and Ms. Nishani Sahoo of third semester Forensic Science to present a case study on the title Use of Fingerprint Surgeries to Fraudulently Send People to Kuwait for Jobs. Over to them.
Good morning to everyone present here. This is Siddhi Pant, Shreya KattiRiya and Nishani Sahoo from third semester BSc Honours Forensic Science. Today, we will be presenting a case study on the topic Use of Fingerprint Surgeries to Illegally Send People to Kuwait. Today, we will be covering objectives such as biological development, types of fingerprint alterations, cases over the world, principal case studies, punishment relayed in India, and conclusion. Now, I hand over the session to Nishani Sahoo.
Hello, everyone. So can we go to the next slide? Yeah. So I'll be telling you the biological development of the fingerprint. So starting with, a fingerprint is an imprint made by the patent ridges on the pad of a human finger. Fingerprint ridges are formed during the 3rd to 4th month of the fetal development. And once the dermal papillae develops in the human fetus, the ridge patterns remains unchanged throughout the life, except to enlarge during the growth, because obviously if the skin surface will increase, the fetal development, dermal papillae, the friction ridges that have created already will increase in the size but won't change. Also to that, the epidermis and dermis is separated by the dermal papillae. Next slide, sir. Now, fingerprint development develops in the fetal life, as we know, and that the most crucial events occur by the early weeks of the 2nd trimester. So in 2nd trimester, volar pads regression and friction ridges development. Also by a week 16, minutiae are set. Volar pads are nothing but a transient swellings of tissue called mesenchyme under the epidermis of palmar surface of the hands and soles of the feet of the human fetus. Sweat gland on epidermal and dermal ridge matures. At the end of the second trimester, sweat duct appears with epidermal ridges. So next slide. Now, as we know, principles of fingerprints, a fingerprint is an individual characteristic. That means no two individuals can have the same fingerprint, which makes the identification easier. A fingerprint remains unchanged during an individual's lifetime, as we talked about it earlier. Only the surface area increases, so does the friction ridges, but it won't change until and unless we provide a chemical alteration or something. We will read about that later. Fingerprints have general rich pattern that permit them to be systematically classified. So we have applied few techniques and patterns such as arch, loop, or whirl that can actually help us classify the proper fingerprints to record the data. Next slide. Now, fake versus altered fingerprinting. So in this slide, we will study about what is fake fingerprint and what is altered fingerprint. Fingerprint obfuscation refers to the deliberate alteration of the fingerprint pattern by an individual for the purpose of masking his or her identity. So as we know, fake fingerprints and altered fingerprints are completely different. In fake fingerprints, in the third line, if you see, in fake fingerprints, we use making of glue, latex, or silicone that will only cover your friction ridge on the surface area and it will imprint it. But in altered fingerprints, we use real fingers that are used to conceal one's identity in order to evade identification by a biometric system. So these things are deeply cut. The friction ridges are deeply cut through the dermal layer, and that's how we can evade the identification system by when we go and show ourselves to a biometric system. According to the changes made to the ridge pattern, fingerprint alterations may be categorized into three types. One is obliteration, second is distortion, and third is imitation. So next slide. So first, let's study about obliteration. So in this, friction-rich patterns on fingertips can be obliterated by abrading. Abrading means the scrape or wearing away of the friction ridges by the friction or erosion. Then cutting, burning, and applying strong chemicals and transplanting smooth skin. Obliterated fingerprints can defeat automated fingerprint matches and successfully pass fingerprint quality control software depending on the depth and area of damages. If the damage does not reach the generating layer in the epidermis, the skin will regenerate to the original ridge pattern in few months of time. So when we talk about this third point, they talk about the does not reach the generating layer. Generating layer, we can talk about 1 millimeter in length, in the depth. And in the last point, if the damage is done to the generation layer, scar tissues will replace the damage area. Not a proper, well-detailed ridge details, but a scar tissue will be there. So next slide. Second, we talk about is distortion. Now, friction-rich patterns on I'm sorry. Now, friction-rich patterns on fingertips can be turned into unnatural rich patterns by plastic surgery, in which portions of the skin are removed from a finger and grafted back in different positions. Friction skin transplantation resulting in unnatural rich patterns also belongs to this. This type of fingerprint alteration has been increasingly observed in border control application, and to that, when transplanted fingerprints can successfully evade existing fingerprint quality software, we need to enhance the software. If the Therefore, it is imperative to upgrade current fingerprint quality control software and to detect this type of altered fingerprints. To add to that, we have here, just a second. When once detected through the detection software, we can actually take following steps to assess that the fingerprint we have taken as an example is automated fingerprint, I mean the searched fingerprint. So first step is to identify unaffected regions of the fingerprint and manually mark the features such as the minutiae. And second is to reconstruct the original fingerprint, such as done by the latent examiner, and they use a Z-cut case. So next slide. Third we talk about is imitation. Here, a surgical procedure is performed in such a way that the altered fingerprints appear as a natural fingerprint-rich pattern. Such surgeries may involve the transplantation of a large area of friction skin from the other parts of the body, such as fingers, palms, toes, or even cutting or moisaicing multiple small portion of the friction skin. The transplanted fingerprints can successfully evade existing fingerprint quality control software. If the surgical scars due to the transplantation are small, it can even deceive inexperienced human operators. The next slide. Now I will hand over the case to Siddhi.
So as we studied about the types, alteration types, so here are some related cases which talks about fingerprint alteration. So the first prominent case was of the John Dillinger. So he was one of the American notorious theft. So he chose acid to burn the tips of his fingers in the late 1934. So the procedure appeared to be successful, but however, after some time, the faint ridges markings were still visible on his fingerprints. Second was that of the Lin Rong. Lin Rong was a Chinese woman who undertook extreme measures to enter Japan after she was deported from the country. She paid about $15,000 for fingerprint transplant surgery and swapped her fingerprints from right and left hand. So what she did was patches of her skin from her thumb and index fingers were removed and then grafted onto the ends of the fingers of opposite hands. So as a result, her identity was not detected and she could enter Japan illegally again. The last one is that of a case of an unnamed man, which was found in the Madrid, Spanish. So Spanish police arrested this unnamed man. He was a drug trafficker who damaged his fingers and used microimplants to avoid biometric fingerprints. But after some time, after his fingers healed, it was revealed that the friction ridges grew again as they were originally developed. Now Shreya would be taking on further.
Good morning, everybody. So let's take on some more examples just to show that the occurrence of such cases is not rare even in India. So starting with the Delhi Youth Con, a 19-year-old person scammed two people of rupees 1 lakh. This was done by misusing the Aadhaar details like fingerprints, as he opened the money withdrawal option using the Aadhaar-enabled payment system. And this system only requires a fingerprint and your Aadhaar number, so you can withdraw money and send it to other people. In the second case, a man removes his skin to get a job, even though this is highly brutal of a description. It basically is a case where a man used a hot pan to remove the skin off his thumb and attach it to another person so that he could help him write the exam. But this is obviously not a right solution to share your fingerprints, because we all know that fingerprints go even more deeper. This man was caught as the invigilator saw that something was wrong, since the Aadhaar identification was not working when he went for the exam. So he sprayed sanitizer on his hand and the skin just peeled off. In the last example, we have, one second. We have a cloning gang in Haryana who paid a government employee got details of the people and proceeded with an online scam of crores of rupees. They used the same application, that the Aadhaar enabled payment system. After using the private details which are not supposed to be shared to the public, they scammed off this much money from our country. The police had to build special groups after receiving multiple complaints, because people were complaining that money was getting withdrawn out of nowhere, even if they had not transacted it. And hence these people were caught under fraud. Moving on to the main subject of our case study, the principal case study of people getting fingerprint surgeries to get back to Kuwait. Why are they doing this in the first place? So Kuwait due to multiple religious reasons, deport their citizens, and Indians being, one of their primary targets, get sent back home. The main issue of getting deported is they cannot go back to the country. Now, since they needed to go back to the country for, financial issues, like one Kuwait currency is equal to 200 rupees in India. So to provide for their family, they sought out adoptions, and one of these options led them to two men. Two men in Telangana. Their name in short, Reddy and Ramana. These people were surgically changing the fingerprints of the people who were deported from Kuwait so they could return. The main identification of people in Kuwait was based on the fingerprints. So if you changed your fingerprint, your whole identity was changed and you could return to the country. So now this fingerprint changing operation was a nationwide one. These two men were moving from state to state searching for clients, because they heard from one example from Kuwait who got their surgery done from Sri Lanka to alter their fingerprints, and that's how he could return back to Kuwait. Now, this duo surgically removed the upper layer of the skin and tissue of the fingertip and restitched it. The wound on the fingers would heal in 2 months, resulting in a slight change of fingerprint pattern, and hence scamming in whole country and sending back the people. Now, I pass on the rest to Siddhi.
So after coming across this various alterations performed by people for different reasons, now we will be proceeding with the punishment. In general, there is not any punishment given under the IPC, which particularly talks about fingerprint alteration. But the four which we heard about in the Kuwait case were booked under the various sections of IPC, which were section 420, which was cheating and dishonestly inducing delivery of property, section 467, forgery, section 468, forgery for purpose of cheating, section 472, making or possessing counterfeit seal, and section 120B of criminal conspiracy, and section 2016 Aadhaar Act. Besides that, until now, there is no law specifically regarding alteration of fingerprints. So with this, we conclude our case study.
Moving on to the last event of the day, I invite Ms. Kavya Priya L and Ms. Akshara B of Mr. to take over the session.
So good morning, everyone. So we'll start with the quiz now. I'll be reading out the guidelines for you. Next slide. So the main theme of today's quiz will be technologies in forensic science. So the first preference to answer the questions will be given to first years. If they're not able to answer those questions, it will be given for the second years. So if anyone wants to answer the questions, will have to raise their hands by clicking the raise hand option in the reaction icon. And the first image is for the one who are using the desktop or laptop. And the second image is for the one who are using phone. Next slide, please. So the quizmaster will find out who raised the hand first and will call out their names so they can answer. Please do not unmute yourself until and unless the quizmaster asks you to. So the students who are not named properly will not be allowed to answer, and the students only with the videos on will be allowed to answer the questions. So we won't be scoring for this quiz, and it's going to be a learning quiz. So feel free to answer, be competitive. All the best to all the participants. Now I'll hand over the session to Kavya.
So we'll start with a quiz. Next slide. The first question. A technique used for increasing the amount of a specific segment of DNA is called. Option A, DNA replication. Option B, DNA amplification. Option C, denaturation. Option D, VNTR.
Kavya, there's a student who's raised hands. Yeah.
Yeah, Ria, you can switch on your video and tell the answer.
I think it's DNA amplification.
Next slide. It's the correct answer. DNA amplification is the production of multiple copies of a sequence of a DNA or repeated copying of a piece of DNA. Next slide. Which of the following is used as a detector in HPLC? Option A, photovoltaic cell. Option B, phototubes. Option C, electrochemical detector. And option D, photomultiplier tubes.
I think it's option C, electrochemical detector.
Next slide. Yeah, it's the right answer, electrochemical detector. Hamza can switch on your video and answer. Analyzer is used in option A, polarizing microscope, option B, stereoscopic microscope, option C, fluorescent microscope, and option D, comparison microscope. You're mute.
Is it polarizing microscope?
You can also try.
Yeah, polarizing microscope, I guess.
Next slide. The answer is polarizing microscope. Polarizing microscope consists of two main components, polarizer and analyzer. Polarizer is used to filter light waves in order to generate polarization of light. Analyzer acts as second polarizer. MasSpec Pen is a newer technology in the field of forensic science for direct analysis and molecular profiling of biological samples. This is linked with which of the following instrument? Option A, mass spectroscopy. Option B, atomic emission spectroscopy. Option C, atomic absorption spectroscopy. And option D, X-ray spectroscopy. Next slide. The answer is mass spectroscopy. Document examiners frequently uncover the original writing of words that have been crossed out with the aid of option A, color photography, option B, IR light, option C, thin layer chromatography, and option D, transmitted light. Raghavi, you can switch on your video and answer.
Yeah, IR light.
Ria, you can also switch on your video and answer.
I also think it's IR light.
Next slide. The answer is IR light. HPLC was discovered by option A, Kirkland and Huber, option B, Ismailov and Schreiber, option C, DeVries, and option D, M. Suit. Ria, you can switch on your video and answer.
It's option A, Kirkland and Huber.
A37, roll number, you can answer. Switching on your video.
Yeah, option A, Kirkland and Huber.
Hamza.
Option A.
Next slide. The answer is Kirkland and Huber. Half-life of archaeological objects can be determined by option A, neutron activation analysis, option B, inductively coupled plasma mass spectrometry, option C, inductively coupled plasma atomic emission spectroscopy, option D, inductively coupled plasma optical emission spectroscopy. Anyone from second years? You can switch on your video and answer.
I think it's neutron activation analysis.
Thank you guys. Hope you enjoyed the session.